Chairman, Chairperson, Ms. Asri, right? Yeah. Thank you very much to introducing me. And yeah, so can you hear me? The sound is okay. My sound is okay.
Yes, it's audible.
Doctor, okay, could you please?
The sound is okay or not? Is it audible?
Yes, it's okay, Dr. Jakir.
Oh,
Your voice
Okay.
is clear.
Yeah, thank you very much. And actually, I apologize for the camera. Actually, unfortunately, my camera is not working. Sorry for that. Okay, so this is Dr. Jakir and from Bangladesh. I'm not Malaysian, actually, from Bangladesh. And I came here a long time ago. It is 25 years. It was 2000 May. Okay, so it is almost 25 years, yes. And I got my master's PhD degree from UPM, University Putra, Malaysia. And I joined at MMU in 2009 and almost 16 years at MMU. And yeah, I taught is many subject here and robotics, control engineering, control theory, programming, artificial intelligence and applications and others. Okay, so without further ado, then we can proceed, right? So let me permit to share my slides. Okay. Okay, so screen share. Can see the slide?
yes, it's visible, doctor.
Thank you. Okay, so as I mentioned, that is my topic will be artificial intelligence in practice. Basically, data pre-processing. Okay, so this is an important part when we design or create a model, AI model. So it is a crucial part actually to data processing, pre-processing part, data pre-processing part before processing the model. All right. So let's go. So this is the flow diagram. So we are talking about that how we take the data from the source, and it can be benchmark data, it can be primary data, secondary data. Data is no problem. Actually, data is available, but we need a knowledge based data so we can collect primary data or secondary data, right? Or benchmark data, we call the secondary data. Okay, so this is the so let me this is my pen, right? So today's discussion mainly is the data pre-processing part, is this one here, right? And I will cover a little bit here the feature extraction and selection, and finally is model building, training, evaluation, little bit, all right, and evolution. I mean that evaluation, right? Deployment and fine tuning the little bit. Okay, so main the data pre-processing. So this is the flow diagram or flow blocks, you can say in other word. Okay, so now before that we need to know about the data set. Data set we already know about. It is a collection of data used in machine learning task, and data, as I told you, that data can be collected in different sources. All right. And what is we call the sample? It is the data record we call the sample. Is data record we call the sample. We need the sample of data, right, to train and to test the data, to evaluate the data. And we have events or attributes, that is we call features. That is also important for pre-processing part. And we have features engineering to get a specific features for the specific task. We need to do that training set, test set, right? And that one will be covered a little bit later, right? So still we are in the data. Actually, it is you see that it is crucial to model, because the model we created, or AI model we created, or AI algorithm we created based on the data. So that's why this is the crucial actually, right? And without quality data, it is impossible to create a good model. And data preprocessing is an important part to qualify the data, or to get the quality data, as we know that. So data preprocessing mainly include, there are three parts. We call the data cleansing or data cleaning, and data dimension reductions, right? Or feature reductions techniques are there, and data normalization. So we need to normalize the data to reduce the noise and improve the model accuracy, right? So in data cleansing part, we need to mainly find out that if there is any missing value in the table data, right? And detect and eliminate the causes of data set exceptions, right? So data dimension reduction, that is we call the feature reductions. We need to simplify the data attributes, all right? And then we will see one by one in the slide, next slide. So as we know, it is for your information actually, that what data scientists spend the most time doing, right? It is not creating a model, it is actually the data preprocessing part. You see here, it is clearly written here, right? Let me check. Where is my pointer? Yeah. Okay, so you see here, the cleaning and organizing data is 60% time consuming here of total timing. So building training set is only 3%. Cleaning and organizing data 60%, more than 50%. So data scientists are spending time to qualify the data. And that's why I told you that it is very, very crucial point here. Otherwise, we cannot create a quality model. The collecting the data sets is 19%, the second highest here. It is also the part of data preprocessing, right? Mining data or for pattern 9%, refining algorithm 4%, right? And others are 5%. Okay, so we understand that is how important for this part actually. Okay, so data cleansing, already we know about that. This is very, very important. And when we do this, and then how to do this, that one we will discuss here. Is mainly the preprocessing operations include the following terms here: data filtering, processing of lost data, processing of possible exceptions, errors, and abnormal values, combination of data from multiple data sources, and data consolidations. All right. And dirty data, what we call the dirty data. Dirty data means that if we see in the table form and there is a missing values, or the data that lacks of attributes, all right? It could be noise, it can be inconsistency, and others as well, all right? Then I can give you an example here, that example of dirty data, and we need to clean up it, all right? And then you see here, if we this table from the data, so it is how many columns are there? 1, 2, 3, 4, 5, 6, 7, 8. Right? It is 8 columns here, right? 8 columns means that we call the column is equivalent to number of features, we call that, right? So number of features are 8 here, and the number of data is the number of rows. Actually 1, 2, 3, 4, 5, 6, 7. So there are 7 data here. So my question is, why we are talking about this is dirty data, right? So you see here, there is a duplicate data. It is invalid duplicate data. You see here, this one and this one duplicate, right? Incorrect format here. You see this one and this one, and suddenly is the ER is coming at the beginning. So this is we call the incorrect format, and it is that it is gender is male and female only, but suddenly coming here a, so this is the invalid value. Misspelled is this one is here, it is, you see here, it is should be Italy, but it is misspelled here. All right, and here is missing values. You see here, there are no values here missing. And this one, it is suddenly here coming the number, it is we call the attribute dependency error. So when we are talking about this value, it is should be female here and male here, right? So it should be is, if you see there, the value is the lecturer, all right, and number of students. So it is lecturer is 0. If 0, then it should be 0. And if 0 here, but here is the number. So that is attribute dependency error. And then this is the country here. This that should be state, but it is written country name. So this is we call the value in the wrong column. So these all are the part of dirty data actually. So we need to overcome this problem, and that is the part of pre-processing, right? There is a feature engineering, right? This is the features actually is in every column, and features engineering is there. Is features we call the input also, in other words, and there is the input here. How many inputs are here? There is the 8 inputs here, or 8 features. So our target to reduce the features, if we suppose it is here is the country and here is the state. So we are thinking that the state name is enough, country is no need. So we can delete these features. We can delete it because this is unusable, it is unnecessary. So we can reduce this one. This is we call the feature engineering, to reduce the dimensions, right? So that is the feature engineering coming, I think, the next slide. Okay. So sometimes the data conversion is important. Data conversion is important. Sometimes we have the text data, so we need to convert into the another form, maybe vector, maybe numerical data. So we need to convert it. All right. It is depend on our applications or specific tasks. Actually, is what tasks we are going to be, model our AI model to develop it, right? So that is depend on that. And again, the data conversion is here, right? That is the that I'm telling you, the data can be converted into word vector or through word embedding. We call that. There is a some model is there. It is word to vec, how to convert it, and there is a BERT model also, how to convert the data from one state to another state. As I told you, that there is a feature engineering, so that is important also to reduce the dimensions of the features or the inputs of the data. Normalize the feature to ensure the same value ranges from input variable of the same model. Right? Feature expansions is there, right? It is the combine and convert the existing variables to generate the new features, such as average, right? Okay, so now is the feature selection method is going on here. So when you're talking about some feature selection methods are there. So how to reduce the dimensions, right? So that we will see there are 3 main feature engineering or feature selection method or model is there, and that one we'll see here in the next slide. Okay, so now we call that one of the feature selection method we call the filter. All right, filter method are independent of the model during the feature selections, and there is a block diagram here. You can see here that traverse the all features from here and select the optimal feature subset. And then it is how to ensure that it is optimal features to train the model, evaluate the model. So if we see that we are getting that good results here, then we can say this is the optimal features. All right. So that is the filter process. All right. There are common method for filter. That is we call the Pearson correlation coefficient, chi square there. There are mutual information there. There is a limitation also. Every method have the advantage and disadvantage. All right. And we have another one that is we call the wrapper method for feature selections. All right. And that wrapper method you see here, generate a feature subset and train a model is together here, and we need to evaluate the model. Then we can see that what features we need to select in this particular task. Okay. And we have wrapper is going on, and there is a sorry for that. On phone is coming. Okay, sorry. Yeah. So there are common method, and that is we call the recursive feature elimination RFE, and there is also the limitation, advantage, and disadvantage both. All right, we have another one, the last one, the embedded one, right? And there is a common method we call the lasso regressions or risk regressions. And there is a block diagram also how it is working actually inside the method. Okay, so that is a general procedure of building the model, right? If you see that, until here we are talking about actually the pre-processing part, the data pre-processing part. Now we discuss about after finish the data pre-processing, and then how we can build a model. All right. So there are three parts: data splitting and model training and model verifications. Right. So after data pre-processing part, we need to do these three steps to build a AI model. All right. So let's see one by one. We can see here. Yeah, so in figures you can see here that how we can model AI model, we can create it, we can build it based, as I told you that we can create a model based on the data. All right, so if data is here and scenario talking about that example of supervised learning, and the learning phase is so this is the use the classification model to predict whether a student score good grade or not in these subjects. All right. And you see here, as I told you that the column is indicating the features, and there is an ID here, level of interest in AI, midterm test results, assignment result, and that is we call the level data. What is level data actually? It is actually the sometimes we call that actual output. All right. So it is the actual output, and the system will give you the predictions. All right. So supervised learning, yes, you know about it, that supervised learning is working is based on the level data. Its level data is given, it is we call the supervised learning, and unsupervised learning is level data is not given, right? So supervised learning, so you see here how we can split the data, and one sample here, 1 to 6. There are 6 data for the training set, and there are 3 data for the validation set or testing set. Right, so we can splitting like that way, and there is a follow service data cleans feature and tag. After pre-processing, we are getting the cleans features and tags here, and we input our. This is the one of the example here. This table, all right. As I told you that this is the features here, we call the attribute sometime, and we have the target data. This is we call the label data. So how it works, the supervised learning model here, right? There is a level data here, and how to train it. We train the model. We are telling that is the level data is given or target value is given. You're telling that if level of interest in AI is high. Midterm test got the 80% marks. Assignment result is 90%. And then we can say it is a good score. If good score, it is yes. If not good score, it is no. Yes and no. So it is telling that if the value, input value or features is look like that, and then it should be yes. So the model can understand that this based on this input value or features, that the model understand that it should be, the output should be, will be yes, right? Because we are already giving the level data to the system, just like that, right? For testing purpose. Okay, so then the model will be trained based on the level data, and then it will be learned, model will be learned, and then we can test the model using the testing data or validation set, right? And it is working or not properly. And that is the process actually. All right. So now it is coming, the when model is ready, all right, and then we are entering the new data. That is how capability of our model, right? So this is the new data coming here in our train model here, all right? And we are getting the predictions. So suppose this is the new data here, and then getting the prediction here. We are getting prediction in the different values. I just told you that data conversion, right? Is it is, you can say it is, there is a threshold value also. Yeah, maybe is 50% below, it will be no, and 50% more than 50%, it will be yes. So you see the prediction value is here. All right, it means say 0.9 means 90%, so we can say it is yes, good grade, and this is below 50%, it is 40%, so it will be, output will be no. So it is yes, it is, it is the threshold 50, so it means that it will be yes maybe, or yes no maybe, it is that line. Okay, and this one is yes, right? So this is the possibility, the prediction for supervised learning, right? So we have unsupervised learning also as well, all right? So criteria, unsupervised learning, for your information, there is no level data, right? Unlabeled data. And criteria of a good model. So what is the criteria of a good model actually? All right. So that is the generalization capability, interpretability, prediction speed, right? And practicability, right? So those of criteria are very, very important to say your model is good, better, or best, right? Okay, so that is talking about the model validity, one by one generalization capability here, all right? And there is some model validity. So we find out the SME is the square mean error or square root mean error, RMSE, right? Root mean square error, mean average error. So there is a many formula to find out the performance, and then we can say that this model is valid, is valid or is strong or not valid, right? So there is a training error, there is a testing error, we call the generalization error in other word, right? There is underfitting. What is underfitting? What is overfitting? So that is all are the parameters to conclude that the system is good, better, or best. It is valid or invalid, right? So what is underfitting and what is overfitting, we'll see in the visual picture we have, and there is written also the occur when the model or the algorithm does not fit the data well enough, then it is we call the underfitting. Overfitting what occurs when the training error of the model obtained after learning is small, but generalization error is large. It is poor generalization capability, right? So that is we call the overfitting. Optimal, yeah, we want actually the optimal, right? We want optimal, but sometimes our model is underfitting or sometimes overfitting, so we have to overcome this type of problem. So there is a figures for underfitting, optimal fitting, overfitting. So this is see here that underfitting here, not all features are learned because of this data. Actually, it is the far from this line. This is straight line. So it is means that when you see here that all data is near to this line, right? It is we call the linear regression, right? So that is we call that, right, optimal fitting. So this is we want actually this one. This is the good model, and sometimes it will be look like that. It is overfitting. Noises are learned, right? We can underfitting, optimal fitting, overfitting. We have some figures also that you can understand better actually. Mainly we need to, total error we call the bias plus variance, and irreducible error. Mainly the bias and variance we need to know about in our model. Total error of final predictions actually, right? So what about the bias and variance of the system here? There is one figure we call here that is what is variance, and that is we call the offset or distance in between two data, and it is we call the variance. And what is bias actually? And it is clearly written here. It is different between the expected or average predictions value and the correct value or truth value we call, sometimes we call, right? This is also the offset, right, or distance. If distance is higher, it is also not good. If in between in two data is distance is very high, that one also not good, and that is we call the variance, and this is the bias. So it means the low variance, low bias are the good predictions, I mean the good model. Okay, so let's see what happened here. The possible combination of variance and bias are as follows, and you see here low bias and low variance, good model. If low bias, high variance, overfitting. High bias, low variance, underfitting. High bias, high variance, poor model. So we have one picture here. So this is the optimal model, this one, the low bias, low variance, right? All data in here. And then it is the low bias, high variance. This is the overfitting, all right? And low bias and high variance, yeah, low bias, low variance. This one is this. High bias, low variance. This one is this. Is underfitting. And this one, high bias and high variance, is this one is we call the poor model, right? There is other figures also using the training error, testing error. So we can say overfitting, underfitting. So you see here, this one is if the high bias and low variance, right? It is we call underfitting. So this part is underfitting here, right? It is underfitting. This side is the overfitting. So how to know that? You see the testing error is reducing, and at the same time training error also the reducing. At this point it is we call the optimal capacity. In this point we call it is the best model or optimal model, the optimal capacity. After that the testing data is increasing here, right? Testing data is increasing here, and although training data is reducing, but testing data, sorry, not data, error. Testing error is increasing and training error is decreasing. Not the point of training error, the point of the testing error. Testing error is the reducing here, at the point it is increasing testing error. So this we call the overfitting. All right. So this side is overfitting, that side is underfitting, and here in this area we call optimal capacity, right? Based on variance and bias, as I told you the earlier, high bias, low variance we call underfitting, low bias, high variance we call overfitting, right? So it is with the bias and variance curve is here. So in this point we call the optimal capacity. Right, there is a to evaluate the model we can find out the mean absolute error. So probably is this formula is not clear, right? So we can see in the Google the MAE. So it is we call the mean absolute error or mean square error here. right? There is a square. This is the difference between that one only square. There is no square. Okay, so that R square also the formula to evaluate the model, right? So we have that popular, it is we call the confusion matrix, all right? This is very popular method to evaluate the performance of the machine learning model, all right? So we can, here we call the true positive, true positive, false negative, true negatives. All right. So what are the true positive, false negative, and true negative? So that is the important parameters we need to know from the data, right? So that is what we call the confusion matrix. So if the term is P means positive and means negative, TP is the true positive. So terms and definition here. So when true positive, this one, number of, you see here, read carefully here, number of positive cases that are correctly classified by the classifier, and this is we call the true positive. What is the true negative? Number of negative cases that are correctly classified by the classifier, right, or by the model. So that is we call the true negative. And false positive, number of positive cases that are correctly and incorrectly classified. And false negative, the same thing here, the number of negative cases, this one, that are incorrectly classified by the classifier. All right. So there are some accuracy and some formula to evaluate the classifier or the model. All right. Use that formula. So accuracy is the TP plus TN divided by P plus N. It means the total positive and number negative images. All right. So that is the formula here, and the misclassification we can find out, the error rate we call, and misclassification rate, sensitivity we can find out using this formula, specificity we have find out using this formula, precisions also you can find out. There is a F1 score here, and then others. All right, to evaluate our model. Okay, so that's all. I think that is from here. I can stop here. I have another class also. Okay, thank you very much for your patient. Okay. Okay, chairperson, just yeah, I just give to you over to you, huh?
Yeah, all right. Thank you very much, Dr. Jakir. So, yeah, students, now we will proceed to the Q&A questions or session, sorry, question and answer session. So if you have any questions, yeah, feel free to ask Dr. Jakir, LU students or MMU students. Hello, do you have any questions? If not, could you please give us some reaction?
Yeah.
Mm-hmm.
Usually, the Malaysian student and Indonesian student don't ask any question, don't want to ask any questions. Actually, usually like that.
Okay.
So, how many students present in this class?
Around 30,
30,
sir.
right?
Around 30.
Okay.
30 students.
Okay.
And most of them, think are from Telu students.
Yeah. So, but MMU is not here.
Okay.
MMU student is not here. All from Telu.
Okay.
The morning session was all our
morning
MMU
session.
student. Yeah, morning
all right.
session was all MMU student with Dr. Hiru.
Oh, yes, with Dr. Haru. I see. All right.
Yeah.
So, yeah, Telu students, will you ask some questions or questions to Dr. Jakir?
Okay, student, any question from Telkom University? Actually, 10 of my student, Dr. Zakir.
Yeah.
Very good.
Yeah, I know. It's all are from AI subject, huh?
Yes.
Yeah. Okay, so we have another two classes, or from my side is another one class, I think we have, right? From your side, another two classes, I think. you will tag in other date, right? Other date and time. Basically, in Wednesday, I think that. Okay.
Mhm.
We
Yeah.
have other lecture class. I think that in next week we have class, right? Is it 7th of May, Dr. Hiru?
Yeah, Pak Heru.
Sorry.
We have another session, right? Another class, another 2 classes from your side next week,
Yes.
and then
Yes.
the following week, right? Is
Class
it?
next week.
Yeah. So okay, so I have also maybe if next week, yes, next week. Yeah.
Okay, Dr. Zakir.
Okay, thank you.
All right. So yeah, if there are no questions, I think we are going to proceed to our photo session. So let's have
Yeah, sure.
yes
But
with the
unfortunately,
students.
my camera is not working.
Yeah, it's okay.
My camera.
Yeah. So students, could you please turn on your camera because we're going to have a photo session together with Dr. Jakir and Dr. Haru from TELU as well as Dr. Jakir from MMU. So let's have a photo session together. Okay. Dr. Jakir, could you please stop share? Okay, that. All right. So are you ready, students? So we're going to have a photo session, before we wrap up our online join class for today, So let's begin. 1, 2, 3, smile. Okay. One more time, Okay. Hang on, please. Yeah. So 1, 2, 3, smile. All right. All right then. So thank you very much for Dr. Jakir as well as Dr. Haru for coming to this online join class for session 2, Artificial Intelligence, and also students from Telkom University and probably some of students from MMU maybe joining also. Yeah, thank you very much.
Yeah, thank you. Thank you
Yeah,
very much.
thank you.
Yeah,
And
nice
then,
to meet you. Yeah, thank you.
yeah, nice to meet you.
And meet you again next week, inshallah.
See you next week. Yeah,
Inshallah.
inshallah.
Yeah, all right.
Okay.
So yeah, students, before you leave this Zoom, I'd like to share the feedback link, and then kindly also complete the feedback, for you to get, e-certificate, Okay. So yeah, so we've already shared to you the link for feedback, so kindly fill out the feedback, So yeah, here I think that's the end of our online join class for today. Thank you very much for joining. And then after you fill out the feedback link, you may leave this Zoom and have a very wonderful afternoon. Thank you.
Thank you. Thank you. Bye-bye.
Ya, terima kasih Pak Heru. Okay, Mr. Zakir as well.
Yeah.
Thank you. All
Bye-bye.
Thank
students
you,
as
Dr.
well.
Zakir.
Okay,
Thank you,
bye-bye.
Dr. Heru.
Yeah, thank you.